Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science. It is all the science that you ever needed in a convenient half-hour package. My name is Chris, and joining me as always, or as usual, I have Claire and Stu. Claire, what amazing science have you got for us to delight our brains?
Oh, well, it's interesting that you mention our brains because this week I am talking about a parasite that is known to affect the brains of certain species. It is, of course, I'm talking about toxoplasmosis. And some new research that has come out about, one of the world's most famous parasites around how it can affect our retinas. And some new research from Flinders University that shows, what sort of how common this can actually be. So,
this is the one we get from cats, right?
This is the one that we get from cats, yeah. And I'll talk a bit more about that because, I mean, I don't know if anybody else has ever, jumped down a YouTube rabbit hole with toxoplasmosis or just a parasite rabbit hole. Any time in their lives, it might be, you're shaking your heads. I thought it was a common thing. Okay, apparently not. But it is one of the more commonly known and also commonly contracted parasites in the world. So, going to be, bring in the parasite this week.
Excellent. I can see Parasites by the dashboard light. Nice little shout out to Meatloaf there. The late, great Meatloaf. Stu, what have you got for us?
With a federal election coming up, it brought to mind past election campaigns. And one of the things that has popped up in numerous election campaigns is immigration as an issue. And look, it's not one of my biggest concerns, I've got to be honest. But I was going to have a little look at how it seems to be a really human concern, immigration. And animals go about migrating all over the place all the time, every year. And nobody says anything to them. But I was going to have a little look at, animals that migrate. How do they migrate? And how do they know where they're going when they migrate? That's a big question that people have tried to answer. But there's also some new research that suggests possibly not all of them do have a really good idea where they're going. And one species in particular I'll be talking about, which there's been new research that shows, maybe it doesn't really know what it's doing at all. So stay tuned if you want to find out which species is the lost migration.
Excellent. Well, birds do it, and bees maybe do it. The educated fleas, not so much. But we will find out which species Stu is talking about very soon. On with the show.
So, Chris, Stu, today I'm talking parasites. And it might be a topic that might make you a bit squeamish, maybe some of our listeners. Because let's face it, parasites can suck. Well, at least some of them can. But this particular parasite we're talking about today is one that is close to us. And you'll understand what I mean by that in a second. And it might be even closer to your pet cat. It is Toxoplasma gondii, which causes the disease toxoplasmosis. And this parasite, I say it's close to a lot of us because it is in an estimated 30 to 50% of the world's population, has at some time in their life been infected with toxoplasmosis, which is a lot. It's a lot of people.
So once you got it, like, do you have it forever, or do you?
No, the infection only lasts a short time. So I think less than a month. And that's because it can't sexually reproduce in humans.
That was my question. Can it pass from human to human?
It cannot pass from human to human. It has to go through our lovable feline friends. And you might, as I said in the introduction, you might remember, if you have been, like me, been down a rabbit hole or a cat hole of parasite investigations. And you might know that, so toxoplasmosis, it is capable of infecting all warm-blooded animals. So it's not like we're special in this respect. It's all warm-blooded animals, but the only definitive host is our lovable feline friends, the domestic cat. And, so it can only undergo sexual reproduction in the body of the cat, no other animals. You might also know about toxoplasmosis maybe if you are pregnant, if you have been pregnant, or you know someone who's pregnant, as it is a parasite that is dangerous to pregnant people and can pass through the pass through the mother's blood and
through the placental kind of barrier sort of thingy?
Through the placenta, and it can infect a fetus and cause a lot of damage.
Right, okay.
There. So that might be why you know about it. And the way that people can be infected with this parasite is either through handling of cat poop. That's why pregnant people aren't supposed to clean kitty litter. Also because it's a gross job, and so why would you want to clean that? And then also by eating undercooked meat from any animal that's become infected with toxoplasmosis. So could be a pig, could be a cow, could be a lamb that you're eating. If that lamb, pig or cow has come into contact with toxoplasmosis through cat poop somewhere, we've got a huge feral cat population in Australia, so it's not uncommon that you might have a grazing animal that comes into contact with toxoplasmosis and have infected meat that is then that then infects you.
So what sort of organism is this Toxoplasmogonii? Well, like what kind of creature is it? Like what sort of kingdom, if you will, or like, what am I looking at here? Yeah,
that is a very good question. So it's an intracellular parasitic protozoan. So it's a protozoa. Specifically, it is a apicomplexan.
All right. So is it?
That's to its friends on the weekend anyway.
So similar to malaria, I think, is some sort of
malaria. Yeah, the malaria parasite is a protozoa as well, isn't it?
I think so, yeah.
Yeah. So there you go. Cousin. What great cousins. You might also remember this parasite because it has been shown to alter the behavior of certain animals that contract it as a parasite. So infected mice and rats will behave differently once they have been infected by toxoplasmosis, and they show a decreased aversion to cat urine, which is another way of saying they're attracted to cat urine, which if you're a mouse or a rat is really not a good place to be attracted to cat urine, and ends up
stinky stuff.
Yeah, ends up, right in the line of the cat who then eats you, and then the life cycle of that toxoplasmosis can continue. But it was generally thought that if you aren't pregnant or a mouse, then an infection by toxoplasmosis can be pretty benign. But there's some new research that's come out this week that suggests there might be more risk for healthy people who are infected by toxoplasmosis, specifically to the retinas of your eye and how common this is. So in a new study by Professor Justine Smith at Flinders University and published in everyone's favourite journal, Ophthalmology Retina, her team analysed the retina photographs of over 5,000 people living in Western Australia, specifically in Busselton, world's longest pier in Busselton. Shout out to Busselton.
Is that why they chose Busselton?
I don't think that's why they chose. Maybe it was. But they had already previously collected this information, and it was and the photographs were originally collected to look at the prevalence of glaucoma, but they went back and they checked the retina photographs of these 5,000 people, but this time assessed the scans for damage to the retina that's caused by toxoplasmosis. So this is a specific injury caused by toxoplasmosis. It's called toxoplasmic retinochoroiditis. So once they'd confirmed the presence in the photos, they then went back to the people whose retinas they belong to and did antibody blood tests to test whether they had actually had a toxoplasmosis infection, and looked at this data to see how prevalent it was within the community. And they actually found something quite surprising. They found that the prevalence of this ocular toxoplasmosis was to be 1 per 149 people, which is quite prevalent.
That's pretty high, yeah.
Yeah, it suggests that this condition is common, which wasn't thought of before, which wasn't something we understood to be a common sort of outcome of infection by toxoplasmosis.
How bad is this damage? Like, would the people have known that they had like vision problems from this?
Yeah, it's a really good question. I didn't get right to the bottom of that, but it can lead to reduced vision in more than 50% of eyes, and even blindness. So it can be a very serious thing. So the authors really want to call out the potential risks about this ocular toxoplasmosis and how we can protect against it. And previous research by Professor Smith had highlighted that specifically, there are meats in the supermarket that might have a high prevalence of toxoplasmosis, lamb being one of them. And it becomes even more of an issue if, our tastes are such that undercooked or raw meat is becoming more common in when we go to restaurants or that we serve up ourselves. So, this is a bit of a public service announcement as well. And in that, it's very important, I guess, to note here that there are 2 very easy ways to avoid getting the parasite. It's either by applying heat or applying cold. So if you cook meat to an internal temperature of 66 degrees, you're going to kill it. And if you freeze the meat, you're going to kill it as well. So that's 2 very clear ways that you can kill off that toxoplasmosis and protect yourselves. And hopefully you can stay parasite free, which, at the end of the day, isn't that all what we want to be?
What are you onto? Anything of interest to the scientific community?
Together, you and I are going to make the greatest single contribution to science since the creation of fire!
It's a big scientific experiment. What do I know?
Across Australia on the Community Radio Network, you're listening to Lost in Science.
Now, we are coming up to an election, and I recall that past federal election campaigns, there's been a whole lot of focus on immigration, which seems to create huge problems for some people who seem to be personally offended by where other people choose to live in relation to national borders. This does seem to be something of a uniquely human problem. Many animals in their natural state are migratory, and they move between countries and even between hemispheres with no passports or problems whatsoever. And it's not any particular kind of creature that migrates either. There are very tiny creatures that migrate, like zooplankton, for example, which isn't really a kind of creature, let's be honest. Zooplankton is a whole bunch of different animals. The category itself means that something else eats them. So zooplankton could be, tiny baby crabs, or it could be just about anything that's an animal that moves around. And there's also very large ones. The largest animal ever to have lived, the blue whale, is a migratory animal. It's a whopper. Now, some migrations are relatively short. Slime molds, for instance, migrate, but they might migrate.
Do they? Really?
Yeah, they can move.
Honestly, the longer I live, the more I find out about slime molds, the more respect I have for them.
There is so much to learn.
Look.
How far do they move, Stu?
Sometimes a few centimetres, sometimes a few metres. But,
wow.
For a slime mold, that's big. That's big migration. But then you've got the Arctic tern, for example, a kind of seabird, has been clocked at an 80,000 kilometre round trip migration.
Oh my goodness. It's a bit more than your slime mold, isn't it?
Yeah, that puts the slime molds to shame. And
wait a second, it's pretty much the circumference of the Earth, 80,000.
Yeah, it's almost. I mean, I think maybe they go one direction and then come back the other way.
Right.
Not sure why they've worked out to do it that way. But obviously, migrations can be for all sorts of reasons. Most are linked to breeding and feeding, more or less. Many animals breed in a particular location and then spend the rest of their time feeding somewhere else and just hanging out. For example, a specific variety of Lamosa laponica, which is a bird known as the bar-tailed godwit, flies from its breeding grounds in Alaska to spend the summers in Australia and New Zealand. So they fly from Alaska to Australia in the summer every year.
Every year.
Yeah,
that'd take a while, you'd think.
Well, they are capable of flying for 9 days straight to make the trip.
Wow.
You think about the size of the Pacific Ocean and the size of a bird, that's a really long time. Really puts us to shame any long-haul flights humans are capable of. I start cracking up after about 9 hours in the air myself. 9 days just would be, I'd be completely around the twist, I think.
You do wonder, I mean, I'm sure you get into how migration works from a biological perspective, but you do wonder how they evolved this. Like, the first bird to fly for 9 hours, or the first one to fly for 8 hours went, there's nothing turning around, going back. There's nothing here.
Yeah, I mean, presumably it started when the continents were a lot closer together, and they just got incrementally further apart each season.
That makes a bit more sense.
Yeah.
Have you noticed anything, guys? This is like getting harder.
Even insects can migrate quite impressive distances, though. In North America, the monarch butterfly completes an annual migration of almost 5,000 kilometres every year.
Wow.
But this is such a great distance, it's not completed by any individual butterfly. It actually takes several generations to complete the journey. So the butterflies that start the migration aren't the ones that finish the migration. They have to lay eggs and go through the whole life cycle along the way. And possibly one of the most famous migrations is the species of salmon, which are spawned in freshwater, and then they swim out and spend most of their lives in the ocean, and then they swim back upstream to spawn a new generation, and then they die back where they started from, which is, one of those classic nature film migration stories. Now, we did mention the mechanisms of navigation for migratory species, and it varies depending on, how they migrate. Birds and some other species actually use the Earth's magnetic field to navigate and sense direction. They have some sort of mechanism evolved to detect the magnetic field of the Earth, and they can, find which way they should be going based on that. There are other animals that use that as well. They think even whales can use that to some degree. The famous salmon I mentioned earlier, apparently they sample the water that they're swimming in, searching for the right combination and concentration of salts that lead them back to the river mouth that they ancestrally originated from, which is pretty amazing. They're just sort of tasting the water. Go, oh, no, not quite salty enough. Oh, too salty, or the wrong kind of salt, or whatever it is. But they're actually sort of tasting their way back home. And obviously, animals on land can use various clues. They leave scent trails left over generations, and obviously they can use visual cues to find their way around the environment and find their way back to where they were or where they've been before, really.
What do the slime molds use on their massive migration?
They use sort of all chemical sensation, but the slime molds are more sort of reacting to the environment rather than instinctively. They don't live long enough, individual slime mold cells, to sort of remember anything anyway, so they're sort of just reacting to environmental cues as well. But out in the open ocean, these kind of clues are not really readily available. The salmon's obviously got a very specific way of figuring these things out. And while we do often marvel at the instinctive ability of these widely variable species to find their way between feeding grounds and breeding grounds, we assume that because they still exist, they must be pretty good at it. I mean, they just keep doing it every year, so they've obviously got it figured out. Some researchers decide to find out how good sea turtles are at finding their way around, to shed some light on how they might complete their annual pilgrimage between their breeding and feeding grounds. Now, it turns out that, kind of like the turtles in the film Finding Nemo, they might not actually have much of a clue where they're going or even the best way to get there. I don't know if you remember the turtles from Finding Nemo, but they were pretty laid back and...
they were basically stoners.
Yeah, they were chillers, surfer dudes, gnarly.
So a team of researchers tracked a species of sea turtle found in the Indian Ocean using GPS data to see how well they found their remote island targets across open oceans, and they found that they often don't take the shortest route to get where they're going. So, in fact, some of them only corrected their course when they came into contact with shallow water. In other words, they were swimming out of the ocean in the wrong place. They went, oh, hang on, I'll turn around and go the other way. Or they hit other islands, and they weren't the island they were going for, so they swam back out and found a different direction to travel in.
So clearly they can identify the island that they're...
There must be other... triggers or clues for them that they can pick up on once they're there. But swimming in the open ocean where there might be hundreds or thousands of kilometres between islands, it's a mystery how they get from one place to another. One of the turtles they tracked swam 7 times further than it needed to go in order to get to the island it was aiming for. It swam a distance of over 1,300 kilometres when it only needed to go 176 kilometres. So,
wow, that is living proof that it is the journey, not the destination.
Well, absolutely. This is especially surprising considering they don't eat while they're migrating. So this means some of them go months without food because they're swimming around trying to find their way back to where they're going, which is, it is the destination, I think.
Yeah,
it's absolutely the destination. They've got to get where they're going or they'll starve. The researchers of the paper, which was published recently, concluded that this particular species of sea turtle has a very poor map sense of the territory, especially if you compare it to some of those more sophisticated species of sophisticated navigation methods that other species have evolved. The turtles seem to be a bit kind of hit and miss. But the fact they continue to make these journeys at all makes me think that they are the real heroes in a half shell. And I'm behind you, hawksbill turtles of the Indian Ocean, and I say to you, turtle power.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook, we're Lost in Science on 3CR, or on Twitter, where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now, where the same time every week, Claire, Stu and Chris get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.